These are the solutions for the study guide for Chapter 6, Section 4, Parts 3 and 4, and Chapter 6, Section 5. So let's take a look at our first problem here. And on this first one, they're asking, does the equation represent a linear or nonlinear function? So whenever something is linear, it means it's a line. That means that the variables, well, a linear equation is in two variables. So both variables must be to the first power. To that first power. And so that's what I'm looking for here. So I see that I've got the two variables. Y is to the first power, but x is to the second power. So we'll say it's nonlinear because the variable x is not to the first power. So on the next problem, it's kind of like what we had been doing in the past where we're trying to write an equation, but we're also trying to solve for this unknown. So it says the table shows the cost y in dollars for X theater tickets. Find the missing value y that makes the table represent a linear function. So whenever we are dealing with a linear function, we can find out if we're going to have a constant rate of change, which is a slope, and that's what I'm going to find first. So I'm going to use the slope formula, and I'm going to take the y values. So 26 and 78, I'm going to subtract those. So 78 minus 26, and then I've got to start with the 6, since I started with 78, 6 minus 2. And so when I do this subtraction, I'm left with 52 over 4. And 4 goes into 52, well, 4 goes into 5, we have 1 time. And with 1 left over, it goes into 12 13 times. So that's 13 over 1 is the slope of that line. So I'm going to use that slope and one of the points into point slope to write the equation, because that's what they're going to ask for. See how they say write a linear function. And so I need to find out what the y-intercept is. It's not given to me, so I have to substitute a point. So I'll take this point right here, 2, 26, and I'll have y minus 26 equals the slope of 13 times by x minus 2. So I'll go ahead and distribute. Y minus 26 equals 13x minus 26. And then I could just add the 26 to both sides to find out what that y-intercept is. Now it cancels out the negative 26, so the equation is just y equals 13x. So that's the equation. Now they want me to find the value of y when x is 4. Well, all you have to do is substitute. Just put 4 in place of x and then find out what y is. So in this case, y is 52 in this case. So y is 52, and that represents dollars. So $52 for 4 tickets. That would be our answer. Well, looking at the next one, it says the graph shows the water usage for a business. Describe the change in usage from July, right here, to December. So December is in between November and January. So I'm looking at from this point to this point. So notice how it's a curve. So whenever I see a curve, that means I need to use an increasing rate or a decreasing rate. And so when I look at this one, again, if it's kind of small, you can exaggerate the picture a little bit to make it look a little bit easier to see. And see how at first it's changing quickly. So it's going fast to slow. And so if it's going fast to slow, that means I have a decreasing rate. The rate is decreasing as time is increasing. So we would say water usage from July to December water usage is decreasing because it's going down. It's definitely decreasing as we go down. The usage is going down, so it's decreasing at a decreasing rate. Well, let's take a look at our next problem. And it says describe the relationship between the two quantities. Okay, so we have dollars and months. Now, this looks like a straight line, and so that's a constant rate of change. So we would say dollars as months increase. And now notice how all the time the graph is never coming back, and it can't really come back because that would be going back in time. So as months increase, dollars increase quickly. And I'll go ahead and say they increase quickly. It looks like a fairly steep line. Increase quickly at a constant rate. Then it changes. So then it looks like it comes straight down. So I'm going to say, then dollars decrease for a short time at a constant rate. And so now I've covered two segments of it. I've got the first two. Then it looks like it increases again. So then we would say then increases for a short time at a constant rate. And then things change again. So then notice how it's kind of almost flat, but it looks like it's going up slightly. Possibly it would be flat. And I would be fine if you said at a stage it said it looks like it remains constant. But I'm going to say it kind of heads uphill. This looks like a curve to me, and it's increasing at an increasing rate. And so I'm going to say that next. Then dollars increase at an increasing rate. And so if you had said maybe for a short period of time dollars stayed the same, and then they increased it at an increasing rate, I would be fine with that, or just increasing at an increasing rate. So now we're supposed to sketch a graph to represent the situation. You're typing or texting a friend at a constant rate. You send a message, wait for a response. Once you receive the response, begin texting a reply at a constant rate. So there's two ways to do this problem, and it depends on what you call your y-axis. And so I'm going to call, the one way would be to say that the y-axis represents speed of texting. And then we would say, if that's the case, we would say the x-axis represents time. Now, if it's speed of texting at a constant rate, then you're going to have a flat line, because that would represent a constant rate of change. Constant rate is what it said. Then you do that for a period of time, then you send the message and you wait for a response. So nothing occurs, so it's kind of a flat line, and then it stops. Once you receive the response, you begin texting again at a constant rate. It doesn't say that the rate changed, it just says a constant rate. So it would look something like that. And so that's one way. Or if you said words typed or words texted, so then it would look a little different. Rather than speed along the y-axis, it's just words texted in a response. So again, we would have time, and you would have no words at no time, and the line would look something like this then. So if it's words texted, you're texting at a constant rate. It would be a line heading uphill from left to right. It would be an increasing line. Then you wait for a response. So you go ahead and send the message, so you're not texting at all. Time elapses, and then you begin texting again at a constant rate, a reply, and so it looks something like that. So either one I would take as being fine. And the next one is definitely one way, and let's take a look at it. It says sketch a graph to represent the situation as the price of grapes increase. Okay, so don't worry about this, thinking of this as a line here. This is just meaning that they're dealing with the x-axis right there. So let's go ahead and put price price of grapes. And then now, and price is just going to increase. It's just going to continue to go out in this direction. Now they're talking about the y-axis. Now the reason I know that is because they use this word rate in this sentence. And so it says, or in this part, it says the amount that producers supply increases at a decreasing rate. Okay, so now you see how they're comparing the rate to what the producers supply. So we're going to put supply right here, or producers supply, so the amount basically, and that is increasing at a decreasing rate. So it's going to look like this. And so it's increasing, but then it kind of tapers off as prices go up. And so that's what that graph would end up looking like. Let's take a look at the next problem. And it says solve the system of linear equations. And it says by elimination, but you could use any method. I actually took that portion, that word off, so it doesn't matter what method you use. For me, I'll go ahead and use substitution, since it makes sense to use substitution when y is by itself. So what I've got left here is x plus 2, but then I've got negative 1/2 x plus 6 equals 12. So I go ahead and do some work. I'll distribute the 2, and I've got x plus negative x, because half of 2 is 1, and then plus 6 equals 12. So I go ahead and combine these two terms. They make 0, and so every variable canceled out, and I'm left with two numbers that do not equal. So what that means is there's no solution. And the reason we have no solution is because the lines are parallel. Or we could have said the equations have the same slope. So either way it means the same thing, but basically the reason is that the lines are never going to touch, and that's what we're looking for, what they share in common. They have nothing in common because they will never cross, at least in a two-dimensional plane. So the next one is one where answers can vary. So answers vary here, so it just depends on how you set it up, and as long as yours makes sense, it works out. So let's see what we were asked to do. Sequence of transformations just means more than one, and we're supposed to map from the original figure, so here's my original, to the image. Now when I do a sequence, what I typically do, if I have to do a rotation, I'm just going to rotate it about a point. And also with dilations, I'm just going to dilate it about a point. And so the first thing I'm going to do is I'm going to go ahead and rotate it about, let's go with B. If I rotate it about B, that means B is going to hold constant. C and A are going to move. And I'm going to rotate it so it ends up, so this line right here is now in line with this line here at x, or y equals 2. So y equals 2 is just a line that's very faint right here. You can see that blue line that goes across. And so BC is going to line up directly with that line. And so it's a 90-degree counterclockwise rotation about the vertex B. And so that's what I'm going to say first. So I'm going to say rotate counterclockwise, CCW, 90 degrees about the vertex B. Now if they did not have a vertex, then you just name that point. So you can name the point, and I'll go ahead and name it here. It is -4, 2. And so once I do that, what'll happen is it'll end up going out this direction. And let's see how far it goes. It goes 1, 2, 3, 4, 5, 6. So 6 spaces. So that's 4. So it's going to come right out here. And then this is 1, 2, 3, 4 spaces up. So 1, 2, 3, and then it'll be up here. So it'll look like this. So once I've rotated it, now I'm going to go ahead and translate it. I'm going to translate it down 1 and then over 1, 2, 3, 4, 5. So the B's are lined up. So that's what I'm going to do next. So translate 1 down, and we said 4 left. or actually 4 right, I'm sorry. So 4 right to get over there. So 1 down again, and then 1, 2, 3, 4, actually 5 right it looks like. 1, 2, 3, 4, 5 spaces. So let's fix that. So 5 spaces right. 1 down, 5 right. Okay, now we've got the B lined up with this B right here. So these are in line now with each other. So now all I have to do is dilate it. Now when I dilate it, I'm not going to dilate about the origin with the center at the origin. I'm going to dilate about the center being at B. And what's going to happen is all the points are going to come in towards B. B is going to stay exactly where it is, though. So A is going to come down to this point, and C is going to come down to this point. So I just need to find out what the dilation should be. So since this side is 4 and this side's 2, and those correspond, I need to go from a 4 to 2. And so 4 divided by 2 makes, well, actually I should do that the other way around. Let's go ahead and fix that to show what the scale factor is going to end up being. And so if I do 2 over 4, that means that reduces down to 1/2. So that's going to end up being the scale factor. If I did it the other way, that just means I have to divide it by 2. And so I'm going to go ahead and dilate with a scale factor of 1/2 with the center of dilation at, and then I'm going to name that ordered pair, 1, 1. And so that way, that B will not move, and it'll stay right there. A will suck in towards this A, and C will suck in towards this C. And so then it will line up perfectly with the other. And there's lots of ways to do it. I could have done this in a different order and been able to get to the same thing. I could dilate about the origin and get to the same point eventually. Then your translation would be a little bit different. But you definitely need a rotation counterclockwise 90 degrees, or you could even do clockwise 270 degrees gets you there as well. So lots of ways to set that one up. You spend $56 on food and clothes. And so what we're trying to find is how much we spent on each, the food and the clothing. So let's go ahead and name some variables here. F equals the amount spent on food, and then I'm going to say C equals the amount spent on clothes. So let's set up our first equation, and it's going to end up being E in there. So it's going to be F plus C equals 56. We spent $56 on food and clothing. You spend 18 more on clothes than on food. So the clothes is 18 more. So I'm going to add 18, or add the food to 18, and that's going to give me the amount spent on clothing. So I'm going to use substitution here. Great method. So F plus 18 plus F equals 56. So I'll go ahead and subtract that 18 from both sides. And that's going to give me 38 equals 2F. And so when I go ahead and divide by 2, that's going to end up giving me F equals 19. So I know I spent $19 on food. Oops, not of food. So on food. Now I need to find out how much I spent on clothing. Well, just take the amount of food and add 18, and you'll get your answer. So C equals 18 plus 19, and that's going to give me $37. So $37 equals C, which is the $37 on clothes. And you can check your answer, see if it matches. If you add 37 and 19, that should make 56. Let's see if it works. 6, carry a 1, 5, that works. So it checked out. So those are the solutions that you see on the study guide this week.